Show by the principle of mathematical induction that for all n belonging to the set of natural numbers, x raised to the power of 2n minus 1 added to y raised to the power of 2n minus 1 is divisible by x plus y. Okay, let us begin. So here we have to consider a statement. So we're going to call the statement as p of n. The statement will be such that we have x raised to the power of 2n minus 1 added to y raised to the power of 2n minus 1. This expression is divisible by x plus y. So this is our statement p of n. We're going to label this as statement number 1. Now our goal will be to verify that this particular statement is true for any natural number n that we pick up. So what we'll do, we'll first verify if it is true for n equals to 1 or not. That means for the first natural number, we have p of 1 such that we have x raised to the power of 2 times 1 minus 1 added to y raised to the power of 2 times 1 minus 1. So this is simply going to give us x plus y, and we know x plus y is going to be definitely divisible by x plus y. So what does this tell us? This tells us that our statement p of 1 is true. Now that we have showed that the statement p of 1 is true, we will suppose that let p of m be also true. P be also true, because we want to verify that this statement is true for any natural number. So we'll suppose that let p of m be true. If this is true, such that our new statement is going to become p of m such that we have x raised to the power of 2 times m minus 1 added to y raised to the power of 2 times m minus 1. So this is divisible by, this expression is divisible by x plus y as well. Fine. Okay, so let's call it statement number 2. Now, using the statement, using the pm, we will need to verify that if we consider the next natural number, which is m plus 1, we have to verify that p of m plus 1 is also true. That means we have to show that x raised to the power 2 times m plus 1 minus 1 added to y raised to the power of 2 times m plus 1 minus 1 is divisible by x plus y. Divisible by x plus y. So this is going to be our goal. We'll need to verify this particular statement taking the help of statement number 2. Okay, now how shall we proceed? So let's take the help of statement number 2. So from statement number 2, since it is given here that our expression x raised to the power of 2 times m minus 1 added to y raised to the power of 2m minus 1 is divisible by x plus y. So what we can do, we can express it as lambda multiplied to x plus y. That means we can express it as a multiple of x plus y. So here we have considered lambda to be such that it is a natural number. Fine. Now we will take the help of this expression. So let's start with the expression x raised to the power of 2 times m plus 1 minus 1 added to y raised to the power of 2 times m plus 1 minus 1. So we'll rewrite this expression as x raised to the power of 2 times m minus 1 added to 2 plus y raised to the power of 2 times m minus 1 plus 2. So this is going to be equals to x squared multiplied to x raised to the power of 2m minus 1. So all we have done is use the law of exponents here. Added to y squared multiplied to y raised to the power of 2 times m minus 1. Now what we can do, we can use this equation, and we only need x raised to the power of 2m minus 1. We have this portion here. So what we'll do, in place of x raised to the power of 2m minus 1, we keep x squared as it is. We can use lambda multiplied to x plus y minus y raised to the power of 2m minus 1. Fine. Added to y squared. Added to y squared times y raised to the power of 2m minus 1. Fine. So this is going to be equals to, now what we have is x squared times lambda multiplied to x plus y minus x squared multiplied to y raised to the power of 2m minus 1 and added to y squared multiplied to y raised to the power of 2m minus 1. So let's keep the first term as it is, x squared times lambda multiplied to x plus y. Now from the second and the third term, we're going to take negative y raised to the power of 2m minus 1 as the common factor, such that it gets multiplied to x squared minus y squared. Fine. Now we have x squared times lambda multiplied to x plus y minus y raised to the power of 2m minus 1 multiplied to, now we have difference of 2 squared, x squared minus y squared, so that can be factorized to get x minus y multiplied to x plus y. Now we have two terms. Now from each of the two terms we can pull out x plus y. So we have x plus y, so that is going to get multiplied to x squared times lambda minus we have y raised to the power of 2m minus 1 multiplied to x minus y. Fine. Now lambda, that's a natural number, m is a natural number. That means this entire expression is some number, and actually we don't have to worry about the value of this number, because as long as it has a factor of x plus y, this simply tells us that we started out by considering x raised to the power of 2 times m plus 1 minus 1 added to y raised to the power of 2 times m plus 1 minus 1, and we were able to show that this equals x plus y, some numbers, some value, let's call it beta, where we have considered x squared times lambda minus y raised to the power of 2 times m minus 1 multiplied to x minus y to be equals to beta, and beta is a natural number. We don't have to worry about the value of beta. So here we have showed you that this particular expression is a multiple of x plus y. Now if it is a multiple of x plus y, then we can also say that x raised to the power of 2 times m plus 1 minus 1 added to y raised to the power of 2 times m plus 1 minus 1. This expression is divisible by, this is divisible by x plus y, and that is what we had to show. Now since it is divisible by x plus y, we can now straight away say that our statement p of m plus 1 is true. Now if p of m plus 1 is true, and assuming p of m is already true, now we can generalize our statement and we can say that the original statement p of n is going to be true for all values of n, for all values of n belonging to the set of natural number. So using the principle of mathematical induction, we were able to show that the statement x raised to the power of 2n minus 1 plus y raised to the power of 2n minus 1 is divisible by x plus y for all n belonging to the set of natural numbers.